Good morning. Let me introduce myself. I'm the moderator for today's webinar. I'm Dr. Chan Kayung from Faculty of Engineering, Multimedia University, Cyberjaya campus. I'm the chairperson for Center of Advanced Devices and Systems, and my research areas are in the realization of smart materials and devices, including smart glasses, windows, solar cells, sensors for energy-saving applications, as well as the developments of Internet of Things for smart farming and agricultural applications. On behalf of the organizer, I would like to welcome all of you to our Humanizing Innovations MMU webinar series. Thank you for sparing us your time to be with us now. To begin, agriculture is a very important sector in Malaysia's economy, contributing significantly to the national GDP and providing much employment for our countries. The government is looking forward to modernize agriculture and introduce more technologies to increase the agriculture production efficiency and encourage young people to participate in this sector. We are honored this morning that we have our speakers here to share with us their perspective on the technology-driven smart agriculture in Malaysia. Our excellent speaker this morning, Dr. Sim Chung Chiap from Sim Dabi. Dr. Sim is a principal agronomist from Sim Dabi Plantation Research. Dr. Sim received his Bachelor of Science in Biotechnologies and PhD in Plant Nutrition and Soil Fertility from University Putra, Malaysia. He entered the oil palm industry in 2006, and in 2018, he joined Sim Dabi Plantation Research to lead the agronomy and precision agriculture program. His research interests primarily centric upon improving nutrient use efficiency and conservation of resources via adoptions of nutrient-efficient planting materials, as well as remote sensing and precision agriculture technologies. He also represents Sim Dabi Plantation in the Peatland Working Group Roundtable on Sustainable Palm Oil. From MMU, we have Engineer Dr. Chan Yikit, who is a Deputy Dean of Faculty of Engineering Technology from Cyberjaya from Malacca campus. Dr. Chan Yikit received his Bachelor's Engineering in Electrical Engineering from the University of Malaya. He obtained his MN Science and PhD in Microwave Engineering from the Multimedia University. He is currently the Deputy Dean and Associate Professor of Faculty of Engineering and Technology Malaysia. He is a registered professional and engineer with Board of Engineers Malaysia and Professional Technologies with Malaysia Board of Technologies. His research interests include synthetic aperture radar design, microwave remote sensing, radar sensor development, and RF system design. In 2021, he was awarded the Top Research Scientist Malaysia by Academy of Science Malaysia. He is passionate of making research impact via remote sensing technology, where one of the focus lies in the precision agriculture. Without further ado, let's invite Dr. Sim, our excellent speaker, to start his presentation. Dr. Sim, your stage.
Hi, thank you. Thank you, Chairman, Dr. Chan, for the kind introduction. So may I request that the slide is up? Right. So good morning, everybody. First of all, thank you, MMU, for the invitation to this particular webinar. And I'm delighted to be here to basically share with you how in Sime Darby actually preparing ourselves in readiness, technology readiness for the next decade, right? So let's move on. Next slide, please. Right, so for today, I've structured the talks in three main components. Firstly, of course, I would like to introduce the industry in general, a little bit about Sime Darby Plantation and the R&D program in line with how we prepared ourselves to innovate ourselves for the next decade, right? And sorry, pardon for that error. And for that, we would then share that what are the past challenges faced by the industry, our current effort to address the challenges, and how we then advance the current effort by adopting remote sensing and precision agriculture technology. Right, next. So first and foremost is that for those who are not familiar with the vegetable oil industry, palm oil essentially are the main source of vegetable oil. And for that, if you notice from literature all over the world, is that palm oil is the most efficient producer of vegetable oils, right? In context of comparison, palm oil produce almost 40% of the global requirements and utilizing only 10% of the land area. Regardless what the narratives are, because of the efficiency, you next. Because of the efficiency of this palm oil, you perpetually find it in any everyday products, starting from your toothpaste down to your coffees and your cleaning detergent. Right, next. So Sime Darby, basically we are the world largest certified sustainable palm oil producer, right? With a global presence in Malaysia, Indonesia, Papua New Guinea, and Solomon Island. These are where our plantation located, and we have refineries all over the world, including the Netherlands. Next. So the R&D program in Sime Darby, and because of our fully integrated role as a palm oil producers, our R&D does not only keep looking into upstream plantation work, but we also move into um, genomic mappings, digital technologies, and also milling capabilities. We have about 5 R&D centers in Malaysia, Indonesia, and Papua New Guinea. We have 3 innovation centers in Malaysia, Netherlands, and South Africa. And the entire team is basically supported by about 200 scientists scattered around this location. Right? So I'm here today to basically share with you our efforts in terms of adopting technologies for the upstream, the plantation use. Right? Next, please. Next. So for a start, I would like to share a little bit of videos as an opening to the presentation. Organizer, may you play the video? Right. Thank you. So, what we have shared just now, can I request for the slide to come back? Thank you. So, what we request just now is basically our effort to prepare the plantation for the next decade. As we all know, plantations industries, agriculture in the general, are very much labor dependent. We utilize a lot of hard labors working tirelessly on the ground in the field under the hot sun. And for that, it is often deemed as not very productive and not very human friendly. So what I've showed just now is basically few processes. For example, shown right now that is that the weeding and pest control used to be done manually. Workers carrying a knapsack going around in the field to spray the field for weed controls and pest control. And for that, wherever possible, next, we have migrate to either adopting drones or even tractors, depending on where the location permit us. In places where the terrains are hilly, the machineries can't enter, we will then deploy drone. In area that actually the terrain are rather feasible for machineries to go in, we will then deploy the appropriate machines as shown in the inset photos over here. Next. Fertilizer application, a core element in any agriculture use, used to be shown over here, applied manually, workers walking around in the field, manually throwing the fertilizer in the field. And for that, we then now move on into, again, adopting machineries. Next. And of course, the most tedious element of this particular process, evacuating the crop that you harvest. For that, also, we try at our best to deploy technologies and machineries. Right. Next. So for that, we don't really just stop at deploying machines. Deploying machines is just the first step of it. Like anything, we need to connect the dots so that all the informations are available for everybody to plan, strategize, or coordinate the work effort. For that, we have actually developed an internal platform in collaborations with other collaborator that we call it SMART. Next. In this particular platform, what we have is basically we pump in all the informations available in our companies in different database from the estates down to HQs and the finance unit to have a seamless information available next for both executive managements and professional to actually decide and formulate the methods to address the problem or to make the entire operations more efficient. Next. And for that, we actually then cascade the information down to the effectors, the workers, the vehicle, or even IoT devices to actually implement these strategies that is actually being planned by people on the ground, right? And we also have to facilitate this. We have the apps for pest and disease monitorings, weather monitorings, profit mappings, and etc. Next. So a good example that I would like to share is basically as simple as manual rainfall recording. Everybody knows weather monitoring is important for agriculture production, and it is used to done carried out using measurement cylinders as shown here. Right, every day the workers would have to go and record, measure the volume of water, and then it will then send back to estates to monitor and also eventually uh, evaluate the performance and put in the correct action plans. For that, we have then in the last 2 decades, we transitioned to next a semi-automated weather stations to basically replace the manual recording with a machine that actually do the job. And you, unfortunately, because of the limitation at that time, we still need a manual, a person to actually go and retrieve the data. Next. So with the onsets of IoT, right, the cloud connectivity, we have now gradually moved into a fully connected, fully automated platforms to actually replace all these measurements that previously required labor. And for that, the benefit of it is that this information is then available real time on the spot to anybody across the world. I can know whether my estate is raining in Liberia or in Papua New Guinea or anywhere around the world as long as the system is put in place. Of course, we do not stop there. Next. By overlapping this information to a spatial map, right, historical data of pest outbreak, we can formulate a early warning system in terms of pest control. We understand the biology of the pest. Next. Next, please. Next. Yeah. We understand the biology. Sorry, can you go back? We understand the biologies of our pest outbreak. And for that, by looking at the temperature fluctuations and the rainfall patterns, we can more or less simulate to a acceptable confidence when would pest damage occurs and when to concentrate the pest treatment. Right, thank you. Next. Another use case scenarios that we are doing right now is basically to maximize the land use, right? We could actually audit and make sure that every single inch of land, the precious land that we have, are planted so that we could recover, we could produce a so-called optimum and maximum output from that particular unit of land, right? And deploying drones and clever precision agriculture techniques, we could actually, next, we could actually detect where are the palms, where are the areas within the field. Imagine 700,000 hectares that do not have palm, vacant palm. We can go in and replace these palms with the productive ones, right? Next. So now moving on to what we try to improve is that apart from detecting the individual palms, whether are they present or not, we could actually monitor and evaluate their growth, right? As shown here from a basic drone image, you could actually see the different canopy size. Next. With AIs and image processing technologies and photogrammetric techniques, we could actually model the growth. And shown in this subset illustration is that where are the small palms and where are the big palms, right? And deploying a tool as basic as NDVI, next, we could actually identify to a down specific palms where are the problematics one, and we could then inform our specialists to go down to the field and basically evaluate and formulate an action plan. So next, what I shared is basically just a drone image to evaluate the growth. Deploying the same principle by looking at how efficiently we deploy our workers, we could actually see that deploying manual workers is not the best solution. We have much vacant spot, non-optimal workers deployment, and for that would result in much potential loss and low crop recovery, right? Next. So with all that knowledge put in place, when we put everything together, projecting a spatial output map, next, we could actually identify area highlight in red. Where are the problematic ones? Next. And of course, where are the areas with good growth and good yield? So we could then identify areas that where the crops are not collected, send the machineries to go and pick up the non-collected crops, right? Next, where the pest outbreak occurs, send the machine to go and uh, influence the uh, conduct the actual treatment. Next, and also finally, where are the areas that requires high fertilizers, right? They are high yield. Correspondingly, we need to give more optimal input so that they could actually perform even better, right? Next. So, next. For us, this has been a journey that we started since 2010, right? And it covers the area of detection and monitoring, right? You're deploying remote sensing technologies. Operation management, how do we track and monitors the implementation of this and the quality of this implementation? And of course, we need to build the corresponding infrastructure so that the information can be connected, made available to everybody in the entire company. And what is most important at the end of the day is to have the correct organization cultures and talent to basically support the entire initiative. Next. So for that, I would like to invite everybody by asking a question is that what is your vision for next decade? And if you have an idea and you're interested to collaborate, please do contact us. Right. With that, thank you. I will pass on to back to the moderator, Dr. Chan.
Thank you very much, Dr. Sim, for the fruitful sharing. Our next speaker, Dr. Chan Yikit from MMU. Let's hear from Dr. Chan Yikit on his perspective on the technology-driven agriculture in Malaysia. Folks, if you have any questions that you wish Dr. Sim and Dr. Chan Yikit to answer you, you may post them in the chat box and we'll address your question towards the end of the presentation. Over to you, Dr. Chan Yikit.
Thank you, Dr. Chan Kayong. Can I have the slide? Good morning, ladies and gentlemen. Yeah, I'm Chan from Multimedia University. So today I would like to share our experience on utilizing the remote sensing for precision agriculture. So before I go into the sharing of our experience, maybe I would like to just explain a bit on what is actually remote sensing, right? So remote sensing, so from the wording point of view, remote means we are actually standing at a distance from the point of observation. And sensing is basically we are trying to use tools or sensor to collect useful information from the target of interest. So remote sensing, combining both words, then it means that we are actually deploying some sensors, okay, at a certain distance, so that we can effectively collecting useful information from the target that we wanted to observe, lah, right? Okay, so remote sensing have been with us quite a long time, right? Okay, in various application. Okay, basically, it have been used for environmental monitoring, which including the monitoring of the activities in ocean, forestry, for weather forecasting, etc., etc. Right. Next. Right. So from the deployment of the remote sensing technology point of view, so it can be actually divided into three phases. Okay, so for the first phase is actually for the data acquisition. So we will deploy various platforms such as satellite, drone, airborne, or even a ground-based system in order to capture the information from the target that we wish to obtain the related information, right? Okay, so the sensor that we use typically are the optical sensor, such as the camera, or it can be a radar system as well, right? Upon obtaining the data, the raw data from the observation area, so we will do the further processing, right? Okay, basically we will produce some images, okay, radar images or even the optical images, so that we can match with our model that we have developed previously, and finally we can deploy the result into various applications. So the remote sensing technology can be used for land use classification, paddy yield prediction, oil palm growth monitoring, disaster monitoring, etc., etc. So it is not limited on precision agriculture, but it also can be used for some others environmental monitoring. But of course, today we will focus on smart farming usage. Right, next. So this is just a listing of what remote sensing can perform in the agriculture, right? So basically, we are trying to obtain various information about the farm, right? The soil condition, the water resource condition, the plantation growth monitoring, and etc., etc. Right? Okay. Next. Okay, so we have started something, okay, in the late 1990s, right, with the modeling of the plant, right? Okay, so as we are deploying the radar sensor example, right? So we need to understand how the plantation will be react onto the signal that we transmit, right? Okay, so modeling will be one of the very important phase before we can move on to the actual field measurement, so that we can predict and also we can analyze the signal that we receive from the raw data, right? And we match with what we have in our model, right? Next. To equip with the modeling, whether the model is correct or not, so the indoor measurement have to be performed. So we have built an anechoic chamber. So one of the purpose is actually to perform the radar cross-section measurement on the plant or the plantation that we are actually wanted to observe. Right, okay, next. Okay, so in 1997 to 2002, we have developed the first radar system to be used for agriculture sector, right? So this radar system is so-called a scatterometer, right? So basically, using this radar system, we are able to extract the radar cross-section for the target that we are observed, right? So the technical specification, such as using in C-band and also full polarimetric, it is meant to observe the vegetation, right? Okay, it's very useful by using a C-band and also a full polarization, so that we can observe, we can obtain the useful information from the target of interest. In this case, will be the paddy field. So this radar system have been deployed onto a boom truck, and this boom truck will carry the radar system to the field, the paddy field, to perform the field measurement. Next. All right, okay, so this is some of the photo showing the boom truck with the radar system and also the ground truth measurement in order for us to correlate the actual growth of the paddy field and with our data collected via the radar system. Right, next. right? And we have upgraded the system into multi-frequency radar system. So previously it's a C band, so now we have include additional band at L band, so that we can gather more information from the target of interest. Okay, again, this will be deployed for paddy field measurement, right? Okay, next. All right, so we have performed a series of field measurement from 2006 to 2008, right? To actually to actually collect the data for the full cycle of the growth of the paddy field, from the nursery and then up to the growing state, and also the harvesting of the paddy field. All right. So through this collection, we are able to collect the reflection from the paddy field, and to match with the modeling that we have already built in the previous stage. So through that, we are able to do some prediction and also some classification using the data that we collect from the paddy field, right? Okay, next. Okay, so that will be the experience of the we are using the radar system at the paddy field. So in recently, we also have gone into the uh, utilization of the remote sensing technology in the oil palm plantation, right? So I believe many of us know that the oil palm actually contribute to the largest GDP in terms of the agriculture sector in Malaysia, right? And of course, the oil palm plantation will face a lot of issue, as mentioned by Dr. Sim just now. Okay, it's very labor intensive, and of course, there are some difficulty, especially to monitor the growth of the oil palm plantation, right? So in order to help the oil palm plantation and the farmer, the farm owner, right? Okay, so we have conducted some um, testing, okay, to so that we can at least helping the farmer to know or to understand their plantation better through the remote sensing technology, in particularly the hyperspectral imaging. Next. Okay, so our idea is we wanted to deploy advanced optical sensor, which is the hyperspectral camera, with the drone, right? So that we can collect the information of the oil palm plantation. And in this particular case, is we wish to obtain the information about the healthiness of the plant, and also the whether we can detect the disease of the plantation, right? So the disease that we are concentrating is actually the Gardnerella disease, right? Next. Okay, so we have done a preliminary testing using a hyperspectral camera that loaned from Hokkaido University, right? Okay, at that time we don't have our own hyperspectral camera, but to make sure that the project is feasible, so we have loaned a hyperspectral camera from Hokkaido University together with some others camera, in order to do the comparison whether we are able to detect using a hyperspectral camera, okay, compared to the rest of the optical sensor. Next. All right, so this is the sample image of we collect from the field measurement. So from the left is a hyperspectral data. So basically there is a multiple layer of the images, hyperspectral images, with different wavelength, right? And we have multi-spectral data from the multispectral camera. Basically, is concentrate on the infrared and also near infrared, and the normal RGB camera, which is the optical data at the most right-hand side. Next. All right. Okay. So the hyperspectral images have been processed by our partner in Hokkaido University. So you can see it is still in grayscale, but of course we have multiple layer. So this is just one of them, 460 nanometer, right? Okay. So with one single layer, maybe we are difficult. There is a difficulty to do further identification or classification. But with multiple layer of these hyperspectral images, then we are able to obtain certain signature for different kind of condition. Right. Next. All right. So this is a comparison between three different types of images. Okay. From the most left, we have the hyperspectral images. Okay. Superimposed in multiple layer, and we have a true color composite, meaning only red, green, and blue, right? And we also have this the true color composite at the center, and we have the normalized differential vegetation index, NDVI, okay, using the infrared and also near infrared data, right? Okay, so at the top right hand corner of the images is actually infected oil palm tree, right? So if you check on the true color composite and also the NDVI images, basically there is no differences can be found from the infected oil palm tree. But via the hyperspectral images, which is on the left, you can observe there are differences from the infected oil palm tree compared to those that are actually healthier, right? Okay, so the coloring are slightly different compared to the healthy oil palm tree. Okay, therefore, we strongly believe by using the hyperspectral camera, we can actually extract or identify the infected oil palm tree. Right. Next. Okay. Of course, using various classification technique, segmentation technique, we are able to identify the infected oil palm tree. Right. So this is the result of the preliminary testing using the hyperspectral camera loaned from Hokkaido University. However, there are some limitation in terms of detection is because number one is the number of band of that hyperspectral camera. It is not a lot, okay, and also due to the drone himself, right? At that time, we do not have a very good drone with a good stabilization of the platform. Therefore, the number of images that we can actually perform the training and also the classification, this actual performance evaluation is limited, right? But via this result, we strongly believe it can be done, okay, meaning healthiness of the oil palm tree plus the disease detection is actually can be performed using the hyperspectral camera. Next. All right, so we have deployed another project, okay, under the International Cooperation Fund, MOSTI, to develop a drone, another drone, right, a customized drone carrying the hyperspectral camera. Right, next. All right, okay, so this is a hyperspectral camera that we deployed. Basically, we have covered the spectral range from 500 to 900 nanometer, right? Okay, and of course, this is in lightweight. The performance-wise, resolution, it is better than compared to the previous hyperspectral camera that we use. Of course, now technology it is changes very fast, right? So we will have better hyperspectral camera to be deployed for this project. Next. Right, so we have conducted a preliminary testing, okay, in April 2021. Okay, after that, we do not have any more field measurement due to the movement control order, right? Okay, right after May and also June, right? Okay, so we will soon deploy or arrange field measurement again. Okay, but we would like to share the preliminary result that we have done in the oil palm plantation near the Palong Timor, right? Okay, next. Okay, so sample of RGB images on the left hand side and the one of the hyperspectral imaging at the right hand side, right? Again, the hyperspectral images is in grayscale, okay, it's the intensity, but this picture is captured at 700 nanometer, right? So we have some others hyperspectral images, same spot, but with different wavelength lah. Okay, therefore with a multiple layer of the information, we actually can collect, or we can actually obtain more information about the oil palm plantation. Next. All right, okay. So before we can actually do the classification, we need to go through some preparation of the data to identify the oil palm tree, okay, and also to tag with the ground truth data, right? So that we will tag the oil palm tree, whether this oil palm is healthy, infected with class what A, B, or C, etc. Right? Next. All right. Okay. So after the tagging of the data, then we will select the different condition of the tree, so that in order for us to train our system. So in this particular case, we are selecting 4 different cluster. Okay. So we have the labor index 1, 2, 3, 4. Basically 1, 2, and 4, they are healthy. All right. 1, 2, and 4, they are healthy, and 3, it is class C of the oil palm plantation, right? So 1, 2, and 4, they are all healthy, but the spectral signature that we generate, they are slightly different as well, okay? Meaning probably there are some differences in terms of their nutrient content. Okay, this one we yet to confirm because we don't have the detailed ground truth data for those. Okay, but basically from the right hand side of the figure, you can observe that there are 4 lines. Each of the line is represent the unique signature of that particular oil palm tree that we have been selected, right? Okay, so we will have one label with labeled the index number 3 will have very different signature or pattern compared to the rest of 3. So that signature, we will use it to identify the oil palm tree condition, right? So the one that actually have a very different signature is actually the one that have infected, right? Okay. So the rest of the 3 very similar one, they are not infected. They are not infected, but probably they have some differences in terms of their nutrient content, maybe. All right. So that one we will need to do further groundwork, right, in order to confirm that. Next. Okay. So the classification of the oil palm plantation, then we can perform, okay, by using the digital signature, not digital signature, the unique signature that we have already captured and processed previously. All right, okay. So this is a sample of processed hyperspectral images. We overlapping with multiple layers of the hyperspectral images, right? Okay, so the right hand side is the classification output. Okay, you can actually observe that the healthy tree are clearly being identified, and the in this case the infected tree, okay, which is class C, have been identified as well. Okay, because basically the signature is very different from the rest of the 3, right? Okay, so however, due to the MCO situation, we have no further data that we can share. We are arranging further field trip in order to relate the healthiness level, okay, of the tree, okay, and also different class of the infected tree, okay, including the early stage class A and B, and C. Class C, no doubt we are able to classify it, okay, but class A and B, this will be the challenge, but we believe with the hyperspectral images we are able to detect them, okay, and of course the next step will be also for nutrient content assessment, okay, of the oil palm plantation. Okay, of course this we will need a lot of ground truth data in order to validate the collected hyperspectral images, right? Okay, next. Okay, thank you. That is all my sharing about our experience in remote sensing technology. using the radar system as well as the hyperspectral images, okay, for paddy field and also for the oil palm plantation. Thank you. Back to you, Dr. Chan Kayong.
Thank you very much, Dr. Chan Yiket. Thank you very much for the very insightful sharing. I think we have seen from Dr. Chan Yiket and also Dr. Sims on how technologies are able to elevate the standards and efficiency of the agriculture industry. Hello, folks. We have our questions and answers session now, and our speakers will address your questions. Please post your question in the chat box. Maybe I can start my questions to our speakers. What are obstacles in large-scale implementations of technology in our agriculture industry in Malaysia? This question is for Dr. Sim. Has it got something to do with the investment or has it got something to do with the know-how? So far, we have seen, I think, giant plantation company like SimW and maybe Genting Plantation. I think they embrace the high technologies in helping the production efficiency. But for small-scale farming industry, we do not see a widespread of the technology adoptions.
I think thanks for Dr. Chan for the questions. It is obviously the first limiting step is the investment involved, as you rightfully pointed. Machineries and drones technologies doesn't come cheap, right? Oil palm, in the end of the day, is a commodity crop. If you look into the dynamics, the economics of it, the planters actually don't make much money, especially if you are a small farmer, right? They probably make about 20 to 200 to 300 ringgit per month per hectare, right? And each machine gonna cost them perhaps six to seven figures. So you need a sizable quantity to be able to afford into capex investment. Second, I would say the knowledge, the know-how to actually implement all this in a cohesive manner. So I feel that this is what is lacking in the industry: the willingness to invest, the affordability, and also the expert knowledge in that. Yeah.
Okay. So Dr. Sims, are you saying that the technology is only effective for those um, um, farmers having a large size of the plantation area, and for those farmers running the smaller size, the technology may not be so important for them?
Correct, because uh, each machine has a effective coverage, the optimum area to operate, right? And if you have a, let's say, 100 acres plantation, your machine could actually finish the work within 2 days. And the rest of the time, you will just park in your store, right? So for that, that's why I think sometimes depending on the nature of work, the uptake of technologies is not to that level yet, depending on the size of the plantation, which will affect the profit, then it affects the affordability. That's why for SIME, what is important in the end of the day is that this technology has to be deployable at a sufficient scale. Right? So we always talk about technology at scale. Right? It's easy to adopt, easy to upscale. It has to tick these two criteria because the uh, uptake by the people in general will reach a certain level. It has to be affordable, it has to be easy to implement.
Okay, thank you. Thank you, Dr. Sim. And we have some questions from folks um, regarding Dr. Chan Yikit's presentation. And there's a question asking some on how the ground truth being labeled? Does research team also involve agronomists to create a ground truth? Dr. Chan Ike?
Okay, so basically, the oil palm plantation, the owner, they have the census data, right? So we use the census data that provided by them, so that we will directly label plantation.
Okay. Following the first questions, there's another question from folks asking on this. Using multiple imaging modality, for example, infra, hyperspectral, etc.
Okay, registration. So we have to make sure that the labeling is correct lah. Okay, so I'm not sure whether that is actually referring to the registration. So the labeling of each of the plant tree across the data, across the hyperspectral images, right? They are consistent lah, and they are correctly being labeled, right? So I'm not sure whether this is referred to the registration. So for infrared and also hyperspectral, if they are two different uh, um, source of the data collected from two different camera, then the registration or the labeling of each of these particular um, oil palm tree, okay, but they must be correctly labeled, right? Okay, so whether they are in the image of the hyperspectra or they are image of the infrared, definitely we need to correctly register them, or else we are not able to compare, right, directly. Yeah. Thank you.
Thank you. Thank you, Dr. Chan Yuki. And these are questions from our folk Kaya Razan Othman. Thank you, Kaya Razan Othman. There's another question from Kaya, and Kaya would like to know, in your opinion, what is the biggest challenges in implementing AI in agriculture field? Dr. Chan Yuki?
So for the academic point of view, I think implementing, I think AI is already a very hot topic now lah. Okay, people are using AI for different kind of the application. Okay, in automotive, in the smart home, and also in this case we will also be using in precision agriculture in order to do the classification. So for us, I think not really have a big challenge, okay, because we can because the AI is the technique is already been there, right? Okay, so what we need to make sure is we have to choose the correct techniques or algorithm to be deployed onto the data that we have collected, right? So the data preparation, that portion we have to make sure that we have sufficient information in order to fit into the system. Okay, the AI training may take sometimes, but of course, if we have sufficient data, I think that will be not an issue for us to perform a good classification. But in fact, I think in industrial point of view, then they more probably will have different kind of view in terms of applying the AI in the agriculture. Because from academic point of view, we can always fine tune our algorithm in order to achieve a very good detection or classification for the particular application, such as the detection of the disease. But for deploying into the actual environment, okay, example in the large scale deployment in the oil palm plantation, maybe there will be a more challenging lah, okay, because of a different environment, different location, etc., etc. Probably we can hear from Dr. Sim about this AI implementation. Yeah, thank you. That is my opinion. Right.
Yes, Dr. Sim, what is your perspective?
Um, I do agree with Dr. Chan Kit about this in a holistic manner. I would also like to add that in from the industry perspective, the biggest bottleneck for us to effectively adopt this AI is that talent. We need the people with the skills, with the know-how that are actually interested to be joining us to work in that particular topic, right? It is very, very difficult right now to attract talent. They would rather work in Tesla, for example, compared to working with Sime Darby, right? That's where the hype are. So for me, it is attracting the right skills to join us in this initiative. So because for industry, if there is a good use case scenarios, once you show the AI actually work in our day-to-day operations, eventually the investment will come to make it happen. So the first limiting step is always getting the talent to make it work.
And that's why I think there's always a good collaboration between industry and universities. I think in terms of talents acquisitions, I think the first contact point will be universities lah. That is what our role comes in here. Dr. Chan, okay? Yes.
Yeah, definitely. So we are actually building the bridge between the technologies and also the application, right? This is what academic, especially for the engineering faculty, right? Okay, so engineering is always act as an interface between the latest technology and also the application, right? Okay, so there are a lot of different new technologies are outside, okay, but how we can actually use them effectively, okay, in the industry, then that will be another story. So definitely we need to help to understand what is the industry need. I think this is definitely a very good, very important step. Okay, to know what is the problem they are faced, and then so that we can provide a, a correct and impactful solution to them lah. Okay, not just a fancy solution, but end up with a lot of redundancy here and there, right? Okay, so we need to help the industry to solve the problem, right? So we definitely the academic will the role of academic is to bridge okay, between the technologies and also the industry what they need so that we can solve their problem. Yeah, thank you.
Thank you, Dr. Chan. Okay, we have a comment from our folk, Mr. Harris. Mr. Harris has commented that industry can work with university to train the new talents. I think this is exactly what Dr. Sims and Dr. Chan Yukit have pointed out. I think so university-wise, I think we can develop some theory, we can test on some new test bed, etc. However, the demand and the actual demand will be coming from the industry. And so I think Dr. Chan Yukit has mentioned that I think the database is a big issue here in order to gather enough database for the recognition for the precision agriculture. And that is where I think the university will need the industry to provide the data and also sharing of the data to prove the theory that university is developing. I think that shows that there's a strong needs in terms of collaboration between universities and also industry. Let's check some of the questions posted in the chat box here. Hi, folks. If you have questions, please post in the chat box. We have Dr. Sin from St. Dabi and also Dr. Chan Yiket from Faculty of Engineering Technology from Malacca. Okay, coming back to you, Dr. Sim, on these barriers in the implementations of the technologies in the farming or agriculture industry. So can you elaborate the role of industry in the technology-driven smart?
Of course, at Sime Darby, we have a strong sense of CSR in terms of pushing the adaptation of technologies and to be more environmentally sustainable. That's why we do put aside certain part of our profit into Yayasan Samdabi foundations that eventually would then as the primary engine to basically fund all these projects, right? So for those who are interested, who are keen, you can always check up the Yayasan Samdabi's website, and then every year they will open to for applications in terms of research grants, CSR work, right? We also have constant dialogue with the ministries, with the MPOBs, right? The government custodian of plantation specifically to actually highlight our need. And yeah, we have long-term engagement with all these parties to tell them our pain points and hope that eventually they will give us some support and some kind of facilities from the government end. And at the same time, we have TOTs, technology transfers, to a smaller plantation, our collaborators. Sometimes we share knowledge with Felda. So we do shares, and that's why we engage in this kind of platforms to make the to share the technologies and so knowledge to everybody to create the awareness of this particular platform.
Thank you, Dr.
Yeah.
Yes. Yeah, Dr. Sim, you can continue.
I also like to add is that we have collaboration with universities. Locally, we have UPMs, we have UM, right? We even have UTAR. Abroad, we have MITs and whatnot. I think next stage is to look into how we can collaborate further with MMU. Looking forward to that.
Thank you, Dr. Sim. Certainly, I think MMU also is looking forward very much to collaborate with SIMDABI through Dr. Chan Yik's team. And the same questions that I would like to pose to Dr. Chan Yik. Can you elaborate the role of academia in the technology-driven smart agriculture industry? To you, Dr. Chan.
Yeah, I think as I mentioned, we need to help the industry. This is, I think this is part of our especially for engineering faculty, right? So we should help the industry to solve their problem, right? Okay. Of course, before we can solving their problem, we need to understand what is their issue, what is the problem that they face, and what is the critical issue that they wanted to solve immediately, right? Okay. So sometimes we in order to help the local industry, right? So I think we need to reach up to the industry. Okay, we need to have a dialogue session with them before we can propose something, right? Okay, so there are a lot of research being ongoing. Okay, and for the previous experience is basically we just do whatever we think that it is useful, right? Okay, but recent year basically the government or even the Ministry of Higher Education and also mostly they have come out with the policy and also the framework, right? Okay, so that the solution will be actually science and technology driven and also socio economy driven, right? Okay, so example for socio economy drivers under the 1010 my STIE, so Malaysia Science, Technology, Innovation and Social Framework, right? Okay, so that is a portion about the agriculture and forestry, right? Okay, so meaning actually academic have to think how to help this industry, okay, the agriculture industry, right? Okay, by by bridging the technology that we already developed, right? Okay, and implement in the real industry environment, right? Okay, so before we can actually implement in industry, of course, a lot of time our technology that develop in house or in university, okay, it is not up to the level that can be directly implemented in industry, right? Okay, so this part we have to really work together with the industry so that we can upskill the current technology that we own in a university or in a research lab so that we can convert them into something that the industry can be directly can be benefit from that, right? So this is the job of the I think this is the main roles of the academic, right? Okay, to turn the technology that we have developed, okay, reach them to the industry so that they can use them should do, right? Okay, thank you.
Thank you, Dr. Chan Yee-Kit. We have a comment from our folks, Mr. Harris. Mr. Harris would like to know the price range of hyperspectral camera Senop HSC2. Any idea? Any idea, Dr. Chan Yee-Kit or Dr. Sim, you can share?
Okay, so for this hyperspectral camera, right? Okay, why it is not commonly used? One of the reason is the costing or the price of can be up to 100 something plus Malaysia ringgit. So it is quite expensive lah compared to the multispectral or normal RGB camera. Okay, so that why this is not commonly used, right? Okay, however, the advantages of this optical sensor, which is a hyperspectral camera, is we can obtain additional information compared to the multispectral and also the normal RGB camera, right? Okay, and actually we are not we in this case we should not think that the owner or even the small farm plantation owner to own this device in order to transform or to digitize their plantation, right? Okay, so it can be always a service that provided by a company, so that the small scale farmer, a plantation owner, they can engage the service in order to obtain the hyperspectral images, right? Okay, so yeah, the sensor is quite expensive, but the images, if we engage as a service, probably the price will be going down, right? So to help the farmer to digitize their farm or their plantation, I think this kind of services is important. Of course, the interpretation of the hyperspectral images at this stage, it will be the job of the academic, right? Okay, to make sure that we have a matured classification capability in order to perform various classifications such as healthiness and also disease detection. Once it is matured, then it will be definitely benefit the farmer, right? Okay, so back to the question, yes, the hyperspectral camera is still very expensive, but I believe when the technology go advanced, then the pricing will be going down very soon. Okay, so back to 2018, the price of a single unit is still like 200 over 1,000, and then I believe now we can purchase with a lower price, with 100 over 1,000 Malaysia ringgit. Right. Thank you.
Thank you, Dr. Chan. Thank you for the sharing on the price for the imaging spectral. And perhaps one last questions for today's webinar. And first to Dr. Chan Yee-Kit, what is your expectation for our government or wishes that you have for our government to encourage our agriculture industry to embrace the advanced technology and big data? As we know, these technologies that you described and Dr. Sim has described, I think they help to improve the agriculture's productions. So what is your expectation or wishes for government?
Yeah, I think for a big company like Sandabi, right? They already have remote sensing technology and IoT technology in place to help their plantation to meaning to understand their plantation. Okay. But for the small scale farmer, right, those that have a smaller size of the plantation, the paddy field owner, right? Okay, I believe they need similar technology in order to digitize their farm, okay, and to understand more about their their plantation so that they can take necessary action to maximize their yield and also the production, right? And minimize the costing. Okay, so the small scale farmer, I believe, what they need is the relatively attractive package, so that they can engage this kind of the services, so that to do IR 4.0, meaning to digitize their farm, right? Okay, so what they need is the attractive package that they are able or afford to engage with lah. So I think our government, okay, through various framework or through various these called what, various encouragement in terms of the through the various government agency can help the local industry, okay, especially the small farmer, able to engage with such services, okay, either in terms of provide more subsidized in terms of digitize this kind of farm, or helping the farmer to obtain the related services. Example, they can start with the IoT sensors, okay, across their farm to obtain more information, right? Okay, so I think that is the government rules in pushing the in terms of the IR 4.0 across the farmer, okay, as well as the small scale plantation, right? Okay, that is my point of view. Thank you.
Thank you, Dr. Chan Yike. And Dr. Sim, you have anything to add on this point from industry perspective? What are your wishes or expectation for our government?
It'll be a long, long list. However, I think in the interest of time, again, the summary would be, I would say, talent. I always emphasize on talent, right? So promoting and helping us to change the perception that the agriculture industry is not welcoming will be of a tremendous help, right? Addressing NGOs and offsetting the mindsets of the newer generations, right? The graduates, that I think would be my biggest wish list. If you notice, countries in China, in Japan, a lot of the people who are working in the big corporation, in the end of the day, after 5 years working, they decided to just go back and venture into farming exercise, right? So I think in Malaysia, we have yet to reach that kind of level. So finger crossed, that would be my biggest wish list.
Yes, thank you, Dr. Sim. I think the government can do a lot of promote call to encourage the young generations to devote their career into the plantations. And even engineers can actually take part in the plantation companies and using their knowledge, know-how in technologies, and AI, in also big data to help the agriculture industries. So I think that is what governments can do, and universities and also industry can work together in promoting this to our young generations. We need young generation to come into the agriculture industry, bringing in the new technologies to help the production's efficiency. Thank you, Dr. Sim, and thank you, Dr. Chan Yike, for very fruitful and insightful sharing. And now we are near the end of the webinar. If there are more questions, we'll address later. As a conclusion, technologies are key towards highly efficient and eco-friendly approaches in our agriculture industry. In order to improve the productivity of our industries, so that our export of agricultural products can be increased and import of foods from other countries can be reduced. In MMU, in our engineering faculties, Faculty of Engineering in Cyberjaya campus and Faculty of Engineering Technology in Malacca campus, we have variety of engineering programs which meets your career ambitions. And our programs are integrated with advanced technologies that play important role in variety of industry, including agriculture, farming, telecommunication, manufacturing, and power industry, and many more. So hi folks, feel free to get in touch with us to explore more information regarding our signature engineering program and which certainly we believe will meet your career ambitions. Dr. Sim, maybe one last point to take away for audience before we end the sessions.
Well, first of all, I would just say thank you, MMU, for inviting us and giving us opportunity to share our work that we have done and also express our wish to the universities that how we could eventually work together. Right. Thank you.
Thank you, Dr. Sim. Dr. Chan, you have any key message to our audience?
Okay, let us, the academic and also the industry, work together for the benefit of the society and our country. Okay, towards digitizing the farm, right? Okay, thank you.
Thank you, Dr. Chan. Thank you, Dr. Sim, Dr. Chan, Ike. Before I end this webinar, I would like to thank our speakers, Faculty of Engineering Technologies, Malacca campus, and Faculty of Engineering, Cyberjaya campus, the organizer of this webinar, the Industrial Collaboration and Engagement Center, and Research Industrial Collaboration and Engagement Divisions, as well as Strategic Marketing, Admission and Recruitment Division, MMU Studio, and the technical support team for making this webinar conducted smoothly and successful. Thank you all, and thank you also to audience and folks who have shared their opinions and also comments here. Every one of us, please take care and stay safe. Have a nice day and see you again. Thank you very much. Goodbye.
And we have some good questions to ask.
Yeah, thank you, Dr. Koo.
Thank you, Dr. Chan, for
you.
giving us a good moderation and a lot of key points to be taken away. As a whole in MMU, we actually also have some other faculties. For example, like my faculty of Creative Multimedia,